Hello, and welcome to the program. Thank you for joining us. My name is Sam Ankerson. I'm the Executive Director of the Bailey Matthews National Shell Museum and Aquarium, coming to you from Sanibel, and appreciate your interest and joining us for Gary Kidder's presentation on carrier shells, nature's original shell collectors. And I see Gary on screen. He is joining us from Houston, Texas, and we're glad to have him here for this program and glad to have him back. I know some of you who are joining for tonight's program were also joined for last month's version, and we're very glad to reschedule this and have you back, and also some new viewers as well to hear about carrier shells, which are um, amazing specimens, and at least as far as the Shell Museum's exhibits and visitation goes, they invite more questions from visitors than I think any other group of shells, and Gary will get into all the interesting things about them. If you have questions, and we hope you will, please ask your questions at any time during the presentation. And the way to do that is to use the chat function. So we're in Zoom webinar. And so to ask your question, run your cursor along the bottom of your screen and click on the chat button and type in your question. And after Gary's presentation, we will get to all the questions, and so feel free to submit those at any time. And I'd encourage you to check out the museum's archive of videos of online lectures we've had in the past, and this lecture within a couple days will also go up into the archive, and it's available through shellmuseum.org. And we've probably got about 25 talks at this point that we've done over the past couple of years, and there's a great range of scientific material, malacology, conservation experts, and just a really nice range of talks. And Gary's will be up there shortly, so feel free to check that out. It's free to access it, and you can, of course, make copy links and send them to whomever you like, so that they can see it too. So with that, I'll introduce our very good friend. Gary and his colleagues at the Houston Museum of Natural Science are just terrific friends to this museum and to the staff here. He's the collections manager for Malacology and Inventory in the collections department at the Houston Museum of Natural Science. And his main responsibilities are the management of the 1.5 million malacological specimens in the museum's collection, and reporting on the overall status of the 2.5 million artifacts and specimens at the institution. So he's a very busy guy, and knows his stuff, and we're really glad to have him here. And we'll hand the virtual floor here over to Gary. And thank you all again for joining.
All right. Here we go. Okay, thanks, Sam, and thank you guys again for having me. This has been a very welcome opportunity to speak with everyone, and so I'm really glad to be here, and I want to thank everyone for attending. So we're going to talk about the carrier shells. But before we get into that, I did want to bring up the event of last month. This talk had started last month, and to be honest, our collection storage facility is off-site. And so when I kind of do these talks, I have to often drive to the museum to do them, and because our building is normal business hours. And so when I got to the museum last month, about an hour early, and I'm getting ready to do this talk, I get out of my car and I look down, and I see this. I see a lucky penny on the ground, and I don't ever think about it anymore. I don't really even see them. They're just one of those things in the background. But I looked down and I was like, this talk is going to be great. And so I picked up that penny and I put it in my pocket. And it's actually here right now. And if you're curious, this is it. I took a picture of it. So I'm like, this is going to be a great talk. This is going to be wonderful. And lo and behold, we had massive technical difficulties about 2/3 into the talk. I was not aware of it. My phone was on silent. Sam's calling. I'm getting text from one of the people at Bailey's, another person from the Bailey's Matthews, going, hey, are you aware? And I'm the only one in this part of the building, so no one can come and get me or anything. And so after many sleepless nights of that, of going, what happened? What about my penny? I started thinking about it. And me being a scientist, I decided to take the most scientific approach to it. And I started looking at all the things. And the first thing I thought was, well, what happened from that point to the issues? And the one thing that kept glaring in my mind was when Sam did the introduction, he mentioned that this was going to be the last talk of 2024 for the Bailey's Matthews. Well, lo and behold, it wasn't, because it's now. So was it Sam? Museum directors have special abilities, and so could he counteract a lucky penny? And I don't believe Sam would do that, because this was on behalf of his institution, and him and I are good friends, and so I don't think it was Sam. So I went back to the drawing board, and I was like, what other scientific thought could come to mind? And then I thought, maybe it's inflation. The lucky penny just isn't what it used to be anymore. So maybe I should have found a lucky silver dollar. Either way, I'm okay with it now. My phone is on just in case. And I'm hoping that this is going to be a great talk. So let's go ahead and get into this. So before I get started, I just want to do a quick explanation of the collection here at the Houston Museum of Natural Science. So as Sam said, we do estimate that our malacology holdings are between 1 and 1.5 million specimens. We're currently still looking at that. In 2019, we built the George W. Strait Hall of Malacology. We redid it from its previous iteration. We went from about 600 specimens on display to 1,300, comprising 44 exhibit cases and about 4,000 square feet of space. That renovation was done in a year, and the curator, Tina Petway, and we spent a month around the clock basically doing installation of those 1,300 specimens. Our current focus as of 2024 is we are working with the Bailey's Matthews National Shell Museum on a National Science Foundation grant. It's being spearheaded by the Field Museum, and there's about 14 to 15 major institutions at least involved in this. We just passed year 4. And the goal of this is to digitize our collections that are focused on specimens collected in the Gulf of Mexico and along the eastern seaboard of the United States. So this has been a massive undertaking for us and for many other institutions, but this is our way of getting our data out to the scientific community, citizen scientists, and students and teachers. So this is really important to us. Our additional goals, again, figuring out that 1 to 1.5 million specimen number, and we currently have about 32,000 specimens on backlog that are waiting to be cataloged and digitized into our collection. So now that we get into the talk, I want to talk about some honorable mentions. These are collectors in the animal kingdom that don't necessarily fit quite the bill of carrier shells, but they deserve a mention. And I want to start first with the green lacewings. They're also known as the aphid lions. These guys are cool. They're very, very unique in that when they're in a larval stage, they will actually attach their meals, the exoskeletons of things that they have eaten, to their bodies as a form of camouflage. It's kind of brutal to do that, but this is what they do. Another one is pretty well known. These guys are called decorator crabs, and they're known for attaching sponges and coral polyps to their exoskeleton. They've been observed attaching them to specific legs and using them almost as like fishing lures, basically, to lure in prey. Once the coral polyp gets a hold of whatever the prey item is, the crab quickly moves it to its own mouth and devours what the polyp had collected. So it's a pretty neat thing, neat behavior that's been observed. And I want to give just an honorable mention to the loggerhead shrike because they're from Texas. They are found in Texas. And their common name is also the butcher bird, which, being from Texas, that's just cool to me. And these animals, while they don't attach anything to their body per se, they do like to take their prey item and attach them to things like thorns and even barbed wire. So these guys, everyone talks about Texas, being tough and being a wild area. And these guys are known to take on prey much larger than themselves, including reptiles, rodents, bats, even other birds. So I just wanted to give them an honorable mention because of, hanging their prey items on barbed wire is pretty neat. Now, you do see a lot of unintentional attachments. Now, when I say unintentional, these are things that are often sessile in their adult form, but will attach to mobile animals when they're in their microscopic form, in their larval form. And so for that, we're talking things like bivalves, tube worms, corals. As you can see here, I took a picture from our collection of a muricid that had a spondylus attached to it. The muricid did not necessarily pick the spondylus to attach to it. That was more on the spondylus's end of finding that as its medium to attach to for its life, basically. There is another carrier there. Again, I would argue with this carrier shell in this photograph that it was probably the spondylus that attached to it. I do also want to point out too, what I find so fascinating with the muricid in the photo is the literal strength of these animals. That animal is already carrying a heavy shell, and now it has attached to it another animal that is at least its weight as well. That is just, I mean, that always fascinates me, the fact that the strength of a snail and what they're able to do. So when I was preparing for this, I was searching for other families or other mollusks that do some sort of attachment. And the first one that I came across was in the genus Scaliola. And this is a very small genus. There's only 9 accepted species here, and they're very small in stature. You're talking a few millimeters typically in size. And primarily what they're attaching to themselves is mostly sand grains. So they're not finding other bivalves or mollusks or materials to attach. It's primarily sand. The other one here, though, this other group, Squameriferum, they call them the sea pangolins, and these guys are deep water Indian Ocean. They've made a lot of news over the years because they're the only animals on the planet known to incorporate metal into their body design. These guys are known to incorporate iron sulfide and like pyrite, like fool's gold, into not only their shell but to their skin. It allows them to live. These guys are deep water, 1.5 to 2.5 miles down. They're living near those sulfur vents that are extremely toxic, extremely harsh environment, and it's not only protecting them, but it's also, we believe that it's giving them a way of dispersal of the materials that are produced from the bacteria that feeds inside of them. Actually helps them digest their food. Okay, so now let's get into Xenophoridae, and I want to talk about them as a whole first. We have 6 genera, under 30 species, so it's a relatively small family, but they're very, very well known, and they're very, very popular, as Sam said. They are all marine. We don't have any freshwater or land species in this family. They're typically going to be found on continental shelves and slopes, and they prefer that tropical and temperate regions of the world. They are sexually dimorphic, meaning that there are males and females. And that is something that we see in mollusks, but we also see, hermaphrodites and the such. So these guys are sexually dimorphic, though. Diet, they're strictly herbivorous, so these are plant eaters. So global distribution. To do this, I got into GBIF, and I said, give me everything in this family that's preserved. And the distributions were pretty much what I expected from the data that's already known. But I was looking at it and I was like, what is going on in Denmark? I asked for preserved specimens, and I don't know of any of these guys coming from that far north. And so I started clicking on the links to the specimen records. And when I assume preserved, I think either recently dead, live collected, or preserved in alcohol, which means it was a live collect and it's now in a wet collection. No, Denmark is advertising fossil carrier shells. Which is great because, I mean, yes, they are technically preserved in matrix, but well played, Denmark. You almost fooled me there for a minute. So Florida-wise, since you guys, Bailey Matthews is out there, I wanted to see what's going on in Florida with carrier shells. And what I see here is, first of all, carriers, this family, they go back about 100 million years. So you're talking late Cretaceous, so you're talking even older than the Tyrannosaurus Rex. Not quite Allosaurus time period, but you're talking T-Rex, Triceratops, older than that. There's two other families of mollusks that go all the way back to the Devonian that were also known as carriers. And so Devonian, you're talking about 358 to 419 million years ago, but these are not related to carrier shells as we know them today. And what we believe is that this is an opportunity to show convergent evolution, to where these two families made it to attachments all on their own. The one I show in the photo here was actually more recent, and it was actually collected in Florida. Actually, some of these are collected in the Fort Myers area. So you can find them, and you can see from the photo, from this fossil, that they were definitely doing attachments. You can see bivalve attachment sites on the whorls of the shells themselves. I wanted to find, because we're a science museum and I often deal with our dinosaurs as well. I was like, what kind of Florida dinosaurs? And then it hit me, I was like, oh yeah, you guys were underwater. Can't show any Florida dinosaurs, sorry. So community commonalities, excuse me. So what binds this family together? A little attachment joke there. First of all, we see the sculpture of the dorsum, the back of the shell, the top of the shell, so to speak. And what we see is that it's very pyramidal in shape. But it doesn't always have the same height. Some of these can be very condensed, and some of these can have a much larger upward spire. And you're going to see some different varieties of that in this talk. The shape of the whorl of the base, though, does remain relatively the same. And the color of the shell, you're going to be talking a lighter white color to a lighter yellow color. And I'll get into some of the reasons why we believe that they are those colors. The width and the shape of the peripheral edge, so the outer ridge of that shell is going to primarily, you're going to find it typically very thin. There's a couple exceptions. I mean, when I'm talking about these commonalities, it's that mentality of every time you try to say that you try to put nature in a box, it's going to tell you, watch this, and it's going to do something completely different. So I try to not say always perfect, or, I try not to use those type of words because nature will always surprise you. So with the umbilicus shape, you're typically going to see that in the middle of the shell. So, and you're going to see it from the ventral side. So from the bottom where the soft parts of the animal is coming out. Oftentimes that's visible, not always. Sometimes it's covered, but it's usually visible there. And for a size range, these guys are not going to get huge, unfortunately. It would be really cool. I would love to see a carrier shell the size of a syrinx. But unfortunately, you're talking 20 to 150 millimeters whole. So before I get into the carriers as most people know them, I wanted to hit the different genera first. And what we see is that for this family, or excuse me, this genus, there's 3 extant species currently. They're using small attachments, if any, typically East and South Africa, East China Sea. You can see with these two, from what we know from every single one we've seen live, they all, for the entire family, that you are going to find them with operculums. So that is pretty much a given for this. Now, the opening of the shell, though, where that operculum is, could be all the way to the edge, to the peripheral edge of the shell for some species, all the way to where there's a flange that comes out. And so I've taken photos from our collection of both the dorsal and ventral side, so you guys can kind of get an idea of what I'm talking about there. And you'll see with these families that there is some variation. So Xenophoridae is one species. And if you're going to look at these guys, I tried to do these in alphabetical order. I would have actually tried to group these more with Xenophoridae, with that genus, because these guys are the ones that, if it wasn't for taxonomy, these were originally grouped into that genus. These guys, one species, native to Australia, very small. You're talking at most, you're talking 30 millimeters typically, but they're going to do the massive attachments to where the shell, aside from that ventral side, you're not going to notice it. Anustus, 4 extant species. We do find these in the Gulf of Mexico. We find them along the coast of Florida. These are the ones, or some of the ones that I'm talking about, to where the aperture or the opening of the shell does not extend all the way to the outer edges. And you can see that in this shot. These guys are also a thicker shell. They don't do a whole lot of attachments. The ones in our collection are typically doing attachments later in life. As you can see in the photo, there's a couple shells attached to the edges, but there's not much else. There's not even many break-off points for these guys. These are two of my favorite in this genus because to me, they're just absolutely beautiful. They start early in life, often doing attachments, but excuse me, and Indicus here, when you flip them over, they're porcelainous and they're just absolutely beautiful. They are extremely fragile. Those edges chip very easily. So when we use these in the collection for photography or research or anything like that, these are two that we have to be very careful with. But I love having them out because they're just fantastic looking, very beautiful species. Ponderiana, for this genus, there's 3 extant species, and you're also going to start seeing, again, back to that thicker shell, not as thick as some species like Strombus that we're going to see out there, but they are thicker than some of the other Xenophora. You're going to see that elongated dorsum to where it's becoming more of that upper spire that I was mentioning earlier and not flattened. And then you also see extensions coming off of the peripheral edges. And I'm going to get into that later. So keep note of that because those peripheral extensions are pretty interesting. And there's a reason we believe for that. Now, if there was a carrier shell that didn't attach things to its shell that is found in just about every book on the planet written with carrier shells included, Stellaria is one of them. And Stellaris is typically first and foremost. Some of you guys may even have books. There was one in our collection. I want to say it was Tucker Abbott. Off the top of my head, I can't remember, but the back cover is Stellaris. These are highly photogenic shells, in my opinion. And what you also see with these guys is that the peripheral edge includes hollow spines. And this is the only place we see that in Xenophora. They do have attachments. If present, they're very small. They're often early on in their development. And what's amazing here is you're going to see there seems to be just like they will attach in a regular pattern, they do the extensions also in a regular pattern. I also, because these are so pretty, I wanted to show you guys the side angle so you can see that hollow tubule coming off the ends of them. And then also when you flip them over, you see these beautiful striking radial lines, and that peripheral flange actually thickens a bit more than you see in other Xenophora. But you can also see, looking at this side here, you can see how thin it is, to where when it's building the shell and it's secreting that calcium carbonate, it's literally wrapping it around previous extensions that it had created. Okay, so now we're into the meat of the talk, Xenophora. There's 14 extant species. Again, this is not a huge family, but there's 14 extant species. They're going to range from 20 to 90 millimeters. And they're going to have attachment objects present on all of their whorls. So the entire life they're attaching. And as you can imagine, they do increase the size of their attachments as they grow. I'm bigger now. I am stronger. I can attach bigger things. I have more surface area to work with. And so you're going to see that here. So let's talk about how do they do this? So this process it's an amazingly intricate process. It can take up to 10 hours to do this. The material that they use is that same calcium carbonate that they use to build their shell. And it's almost artistic in some ways because they're not only cleaning the edge of their shell where they're making the attachment, they've been observed cleaning the object of attachment. And so they're trying to get rid of any particles or anything else that may prevent a perfect seal. They're also pushing in sediment or pushing in calcium carbonate into areas to where they can fill in gaps to make that perfect seal. They're also selecting objects that are not typically smooth. Now, again, I will show you an exact opposite of that comment, where they did pick something smooth, but they're going to typically try to select things that are not smooth because the more surface area you have, the more the easier it is for me to attach that object. If you look at the human skull, for instance, the suture lines between the different bones of our skull, they're what we call complex sutures, meaning that they come together like this instead of being simple sutures. the more attachment points in between my fingers, the more it's harder to break. And so they're finding things with more surface area to make that attachment. Now, to do this, it's almost a contortionist act, because they're using both their head and their muscular foot. So what's been observed is when they're doing an attachment, they will take the top of their head between their eye stalks to hold part of their object in place, and the part of their muscular foot. So that would be like me trying to attach something to my arm and using my head and my legs at the same time to do that. That is a very flexible body form that I do not have. So it's very impressive the way they do that. The objects are typically positioned radially. And so what do I mean by that? I mean, they're pointing out and they're not lateral. So you're not going to see them pointing. So if I've got a pointed object like a pencil, I'm going to attach the tip or the eraser end to my body. I'm not going to attach the wooden edge of it. And I'll get into that, or potentially why, and I'll also show examples of that. Also with that, what we've seen is that they will typically, when they're attaching bivalves, the opening will be facing up, and the opening of a gastropod, a snail, will be also pointed up. Not always, but you will see that more often than not. The specimen I selected for this image is case in point of that. And one of my thoughts on this is that by pointing the opening up, that reduces drag. And that is just something that you don't, if you can get away with not having any additional drag while you're moving, you're going to go for that. Okay, so with that, the proper position for corals. So this was a journal entry that was actually published by Feinstein and Cairns in 1998 in a fantastic journal called The Nautilus. Many of you may be familiar with this. If you are not, it's actually published by the Bailey's Matthews National Shell Museum and Aquarium. And the editor would oddly enough be Jose Leal, the head curator there. So when I was preparing for this talk, I was pulling all the available resources I had, and this was one of them. And I find it fascinating, and I like this because it matches up with not only what I already knew, but it matches up with our specimens, which I'll show here in a minute. But what this study talked about is that they looked at existing specimens in museum collections, and they said that their attachment methods and the positioning was beyond random, meaning that it was done in certain ways too frequently for it to just be done by chance. And so what we see here, of the 359 out of 498 specimens that they looked at with coral polyps, they were positioned on the long axis rather than the lateral. And what that means is that's going back to my tip of the pencil or eraser of the pencil being pushed onto my arm versus the wooden length of that pencil. So that's well beyond random behavior. You're also seeing a down and out orientation significantly more times than it would be if they ignored that orientation of that coral polyp. What was interesting here too was when these specimens were collected, 4% of the corals were still alive. Carriers are known for typically collecting dead, but in this case, they were collecting live, and that's pretty neat. On a side note to that, 2 of the coral species that they had picked up on these carrier shells were completely unknown to science. So we were able to name new coral species off of what the carrier had selected. Hence, original shell collector, original coral collector. Pretty fascinating there. The benefits of this study is that it also increased the size range of one of the coral species, and it extended the geographic ranges for 29 other species. So by these carriers picking up things, they're actually extremely useful for research. Carrier shells are obviously they're snails, and they're not moving a lot. They're not changing huge geographical range. They're not like birds that migrate huge distances. And corals, they are dispersal, but they're not dispersing extreme distances either. So you can assume that if they're finding them in an area, that those species are endemic to that area. Okay, so going back to the HMNS examples, these are 2 specimens also showing those coral polyps attached just the way we expect to find them. They're positioned down and out, and they're positioned with the pointed ends being closest to the body, not that lateral side. It's nice to have a museum collection so large that I can go in there and go, that's exactly what we're talking about. This matches perfectly. So the other thing I want to talk about is the unusual cases. I love our bizarre shells in our collection. I love our aberrant forms, and I love finding things that shouldn't typically be found on carrier shells. And so I want to talk about a couple of the unusual cases, even in our own collection. It is not uncommon to find shark's teeth. It is uncommon in some ways, but you do find them occasionally. So that is known, but you will find shark teeth. And so this was one when I was working and preparing for this talk, I found there's my shark's tooth with the point attached to the edge of the shell. Perfect. What I was looking for. Now, the one to the right that I circled, this one is on display in Strake Hall, and this one's pretty rare. That is a piece of wood attached to this carrier. Which meant that when this specimen was collected, that, first of all, that wood had to sink, had to be deluged with water enough for it to sink to the ocean floor. The carrier had to find it, select it, add it to its body, and then it had to be collected before that wood deteriorated completely to where it was just a remnant impression left behind. So that is a fantastic specimen. That is the only example of wood we have attached to a carrier in our entire collection. And like I said, it was so of note that we put it on display. Not putting smooth things. I call this little guy down here my overachiever because he's got a little fragment of a volute attached to him. And it's actually, I was looking closely at him, and it's not the most peripheral edge. So as it looks right now, that volute is almost the size of his entire shell. Well, it was probably bigger than him when he selected it, hence my little overachiever. And he also selected one where it's smooth edge. Like, dude, you don't normally do that. Thank you for being the exception to the rule yet again. One of the ones that I'm always keeping my eye out for to add to our collection, you occasionally will find them with the old school Coke bottle cap tab removers. You'll find them with coins occasionally. Unfortunately, we don't have any of those in our collection. As I mentioned, that's why I'm kind of keeping my eyes out for those. Okay, so let's start talking about why they do this. And obviously, as I'm saying, the best offense is a good defense, and that is going to be what we're going to talk about here. But there's four main schools of thought on why they attach things to their body here. So the first, it would be that visual and tactile camouflage. And I'll get into each one of these independently. Olfactory scent detection is another reason, local motion methods, and an additional size benefit by being attached, by having attachments. I promise I did not pick up a pile of rocks and just put them on a table and went carrier. There is a carrier under there, but that's how well some of these guys will do their camouflage. So let's talk visual and tactile camouflage first. So you have this full coverage versus no coverage, and we've seen that for this entire family. Some no coverage, some full coverage. What we see also with this genus is that the shallower the water depth of the specimen or the species in this genus, the more attachments we typically find. And that makes sense because there's more to pick from. But also, the deeper water you go to, fine, there's less to pick from. But if these guys were really selective and they tried to pick up everything around them, they would stand out at that point. Envision it like this: animal, rocks all over it, thinking it's camouflaged in an area with no rocks. That is like leaving your car in an empty parking lot. It is immediately noticeable the moment you walk out of the store. That's how these guys would look. The shape and color, that yellowish, that light white color to yellowish, actually works with no covering. That actually works well for natural camouflage on the ocean floor anyway. If you've ever been out diving and you've got your goggles on and you're looking around, that yellowish color actually blends in really, really well with the ocean floor. You can also see with camouflage, whether it be a dead shell or a rock, that improves their lack of interest. Animals like to typically, unless they're scavengers, they're typically going to eat live. And with this, what they're attaching typically has, even if it is a dead bivalve, you're typically not finding them with any live or any flesh material on that shell that they attach. For olfactory scent detection, this is pretty cool. And I've taken a picture from the side angle on top of one of our boxes here to show what's happening here. If you remember earlier in this talk, I mentioned how they had the peripheral flange coming down. and coming down into extensions. Well, that's what this specimen is doing here, but with rocks instead. So why am I bringing this up, and why is this so cool? Well, what this is allowing is that it's allowing the soft parts of the animal to not actually touch the ocean floor. And I'm going to get into locomotion here in a minute in the next slide. But that allows, so what we're talking here is scent trails. Anytime a mollusk moves or a snail moves across your patio, you're going to see that trail that it leaves behind. All right. That works as not only as an indicator for our eyes and for other animals' eyes potentially, but it also works as a scent trail, which could lead predators directly to it. The only time that this animal is actually touching the surface of the ground is when it's either moving, which I'll explain in a minute on how it does that, or when it's feeding. And when it's feeding, the only thing that it's actually touching the substrate is its mouth. So, and what these guys, since these are herbivores, they're also grazers. And if the area is plentiful enough for them to graze, they may sit for an extended period of time with nothing around, with none of their soft parts touching the ground except for their mouth, and they will eat literally all of the material underneath them. And then only then will they move on. So as I said here in this slide, the feeding, it requires limited contact, and they're not really leaving much scent behind. Now, the next point, I don't want to get into this too long, but my cat tells me all the time how much of a genius he is. And one of the reasons he says that is because I cover my poop. Well, in some regards, that is an extremely unique behavior, but it has been one that has been observed. Schenck in 1969 observed this in one species of carrier shells in Xenophoridae, in this genus. And to be honest, if you really start thinking about animals that do that, that is very uncommon. And what that is that is also one method of covering your scent. And that to see that we have a snail species doing that, that is really fascinating, to be honest. So moving on from that, let's talk locomotion instead. So their movement here is actually a leaping movement. Your slugs on your patio or the snails on your house or in your yard, you're going to see that they do a steady progressive movement across whatever substrate they're on. These guys don't actually do this. It's been called a leaping movement by Morton, Lindsay, and Yokelson called it a one-legged stomp. And so what that is, so that operculum that they have that I mentioned before, they plant that directly underneath them. Their foot is extended perfectly vertically almost, and then the shell is extended out like a leaping movement about half the diameter of the width of the shell. And so they literally create a gap from where they were to where they go. And you go, well, why is that important? Well, that also creates a gap in their scent trail. Animal predators following that scent trail, and then all of a sudden it disappears, and they may take a right turn when that shell actually took a left. So that actually helps it quite a bit. What I show here in this photo, I want to show off this specimen a little bit too, and just go into how amazingly, how the amazing survival methods of these animals. We collect aberrant forms in our collection. And what aberrant typically means is that the skin, the mantle that produces the shell, when it gets injured, the shell doesn't form properly. And that's exactly what we saw here. That skin, that mantle got injured early on. Those whorls should be fused together, and they weren't. But it didn't injure the entire mantle. The mantle was still able to start producing that calcium carbonate to create the attachment points. So I don't know. This is the only aberrant form in our collection, and I just kind of wanted to showcase that in this slide and just show that this guy survived that. And you know, maybe it was that leaping movements that saved him. Okay. So talking about size. So when we add, yeah, you better chew your food, as every child, including myself, has been told from a very young age. For those of you guys that were playing the game of, I bet you he won't bring up another fossil. Well, sorry, you lost. I wanted to show two of our specimens that we have, one of which is on display. These are two fish species that choked to death because they didn't listen to mom, and they choked to death on a fish they were eating because they just couldn't chew their food. When you look at carrier shells are very, very thin. Adding attachments like rocks, other shells, pieces of wood, bottle caps, it increases the size of that shell, and it makes it a harder bite. Animals don't like breaking teeth when they bite down on something, and it also increases that total width and height. Another observation that was made in the literature that I was reading prepping for this was that, you know, we all know of moon snails, how they will drill holes into mollusk shells and kill the animal and feed on the fleshy material of the animal after they've done that. And two of the papers I was reading talked about how going through museum collections, they'd not observed any drill holes on any of the carrier shells. And I was like, I was interested. So I went back to our collection upstairs and I started looking at them again. I can't find any either. So it's pretty interesting. And that might go to that extra armor. That just might not be a preferred food source for animals that do that drilling behavior because they are so armored. Okay, so we've talked about all of that. So let's talk about now that functional support with these. Now, what I'm talking about here is it's called snowshoeing. So one of the arguments is that by adding extra extensions, you're increasing, you're distributing your weight. Think about snowshoes in the Arctic. But that's not exactly, that's one of the arguments for why they do attachments, but I don't necessarily completely agree with it. Because if you notice the way that they do their attachments, the attachments, if you look at snowshoes, you have fine wires coming out of the middle where your feet are going to a wide extension around the edges. And that's not what we see here. We only see the points going out. If you were creating a true snowshoe around your shell, you would be doing that lateral. The wooden length of the pencil would be what you were attaching to your body potentially. That's not what you see. You see pointed ends. And these guys are found in sandy and muddy substrate where pointed ends sink. So it might not be necessarily for snowshoeing. The other argument here too is that it's for shell stability. And that very well may be the case. We do know that these species can right themselves once they've been flipped over, but it does take them quite a while to do that, and it's a lot of weight. All these extra attachments, so it's an energy intensive process. So this might provide extra stability, whether they're bumped by another animal or they're in areas with high currents. It very well could, and it could help to weigh that shell down. So that is a possibility. So with all that being said, what is the right answer? And honestly, I'm going to come at this and go, I really can't give you one answer. When you're comparing this family of snails with thick shells versus what these guys do with thin shells, you can look at them and go, is it more energy efficient the way they're doing it? Well, that's possible. But then you're also talking the energy required to carry around something so big. So is it a different method to get up the mountain? Possibly. You also look at the size of an animal is often dictated by the availability of resources. So with these guys, they don't get actually completely massive, and so by adding extra size, it does prevent them from being eaten, and it gives them camouflage by having more attachment points. But you're also not seeing them get much bigger to where there are materials that they could select that would be big, that if they were bigger, that they could continue to add even larger things. I don't know. And when you look at the size of, okay, when they're younger, they're attaching things versus some species in this family to where they attach all their entire life. What I believe here is that it's not a one size fits all approach to this family. They have many things in common, but they also have many things that separate them from one another. And I don't think that any one species has the market except for in their own unique environment. Yeah, I don't see that. So I guess my conclusion here is that all of the answers and all the different ways that this family does things, whether it be no attachments, small attachments, many attachments, they all could be correct. What I think is more enjoyable when I do things like this, and I sit back and I'm trying to analyze, you know, what works, what doesn't. Maybe it's better just to stop and look and enjoy the fact that they are as diverse as they are. And that's what I have for you. So I'm going to hit stop share and we can open this up to questions and answers.
Thanks a lot, Gary. Great presentation. Your passion for the intricacies of the biology and the dynamics is infectious, and your thoughtfulness is also really spot on too. So thank you very much. So encourage folks to use the chat function to send in their questions, and as you do, I just had one which doesn't relate um, spot on to the talk, but you mentioned at the beginning of your presentation the Strake Hall of Malacology at the Houston Museum that you worked on that reopened a couple of years ago. Can you say a little something about how carrier shells are represented there? And I would just say to folks, who are watching that this exhibit at Houston is absolutely amazing. It's stunning and is the best exhibit of shell, public exhibit of shells in the US. So it's amazing. But I mean, are carrier shells represented sort of prominently there, or kind of interspersed throughout, or how does that work?
There, but camouflage. No, they are. So the thought for the hall, Tina's brainchild on this, the previous iteration of the Strake Hall of Malacology was that we had separated the hall mostly by family. For this hall, the story that Tina wanted to tell was life on the reef. And so what we've done is we have divided them by theme. You have herbivores, you have predators, we even hit land and fresh water. For the carriers that we used in the current hall, we actually did do a case of active camouflage. That's where you will find them actually. We did an entire case of basically some of the molluscan best camouflage artists. And I would say by far the carrier shells make the top of the list, because many of the camouflage specimens we used in the collection were ones that it was corals attached to them, that it was the coral that did that, or the sponge that did that, or the camouflage was just one of extreme color or shape. So yeah, so they are featured in the hall, primarily in our camouflage case. I believe we might have one in the herbivore section of the hall. Yeah, that's a good question. I should have looked that up. We have 1,300 though, and it's hard to remember where all of our children are.
Right. Well, they're there, and encourage everyone to visit. So we do have some. So we'll move to the chat room here. All right. So Ellen asks, what species is covering their feces?
Oh, wow. Wow. You know what? I will, let's see. I wrote that down in the slide, actually, because I thought that might come up. And it was only observed in that one species, but that doesn't mean, I believe it was regularis. Actually, you know what? You could always get back to me on that, because I wouldn't mind pulling that article again. I've got it on my desk at our storage facility. So that's the thing too. It was observed in one species. That doesn't mean that multiple, I mean, honestly, that had to have been one of the most interesting days at work. Honey, how was your day? And the scientist husband comes home, or scientist wife comes home and goes, "You're not going to believe what I saw today." I don't think that happens very often. In going with that, I have actually never seen these. I know they have been in aquarium exhibits before, because a lot of the research is done off of observation. But I don't know of any aquariums currently that actually have them in their aquariums. So, yeah, I mean, that's kind of one of those questions where it's like that perfect moment.
Yeah. Right.
Yeah,
Hello.
yeah, exactly.
Okay. Kathy asks, is there a quote normal lifespan for carrier shells?
Good question. Okay, so I want to say that was, man, it wasn't long. I want to say, I'm going back to what I was they, in the wild, you're obviously not going to have any idea. And I want to say it was under 4 years, I believe, in captivity. And even then, again, I don't know of any current museums. I mean, that's the best way to tell. And that being said, also, animals typically, especially in aquariums, will live longer in captivity than they do in nature, because of lack of predation, hopefully, in the aquarium. Yeah, the number one question I typically get when I'm walking through our malacology hall is, how long do these animals live? And the oldest living animal on the planet is found off the coast of Iceland. It's a bivalve, and those live over 400 years. But when I was in college out in West Texas, there was a freshwater species of bivalve that lived only, its entire lifespan was only 9.
Right.
So, you know,
Huge range.
exactly. And
Yeah.
I mean, we have some species in our, some of our shells, you expect 30, 40 years. And it varies from species to species. There's over 100,000 known molluscan species. Yeah, yeah,
Right.
yeah,
There's a lot to learn.
yeah.
Okay. Carrie asks, is there any thought of what makes a carrier shell find something suitable for attachment? You touched on that a little bit, I think.
Yeah, and you know what? It's interesting. That's a good question. We have some in our collection to where it's a gamut. They've got gastropods, they've got bivalves, they've got bits of rock. But then there are others, it seems like they get into a pattern to where they will select only rocks. I showed a photo where it was primarily only bivalves.
Mm.
Is that individual, is it one of those behaviors to where this worked one time and it continues to do so? It does seem, and I hate to anthropomorphize any animal, but it really does seem like some of them get into habits. They seem to select the same thing over and over. And then there's some that are like those free-spirited individuals that you and I all know, where it's like, this is cool, that's cool, that's cool, like, look, a
Yeah.
butterfly, and they run off and they
Mm.
grab something else.
Mm.
So yeah, yeah.
Cool. Ariel asks, what's your favorite carrier shell?
Uh,
That's a Gary
I,
question.
I am a big fan of it. To me, I consider them the most, okay, so Sam and I, his museum and ours, we deal with a lot of shell collectors. We go to a lot of conferences with citizen scientists, and we attend Conchologists of America every year. And a lot of that is interacting with shell dealers and shell collectors. And there are some collectors out there where they will try to collect all of one family or all of one species, or all of one species but multiple color forms. For me, I consider carrier shells the most dangerous of them, especially for me. I don't necessarily collect any more because I work for a museum. Um, and that's a borderline of conflict of interest, having a private collection versus managing a public trust like the museum's collection. Anyway, when I was collecting, I considered them the most dangerous because it wasn't necessarily the species, but what was attached to it. You could have, for Palladula in particular, I could have 10 of them, and they all look a little bit different because they've all collected different things. And going back to my talk now, what I look at is those attachments and the unusual ones. I'm telling you, you wouldn't believe how excited I was when I found that fossilized shark's tooth on the one that was upstairs in our collection. I was like, that's perfect. Not only is it perfect, but I have used that. We do a lot of school summer camps. They get to come to our collection storage facility. And that's one I always pull out for the kids to see because sharks are cool. And now
Mm.
I've got a snail that's cool by attachment, literally,
Mm.
having a shark's tooth with it.
Mm. Mm. Yep. Catherine asks, any reproductive information?
Just that they're sexually dimorphic, male and female. Yeah. And you're typically going to see just dispersal behavior. But yeah.
Yeah. All right. Paul asks, do they ever attach a shell to another shell that is already attached to the carrier shell? It's
Okay.
also like a riddle.
Yeah. So we have two that are attached to each other in the collection. I'm not sure how that worked out. You got to think about this. And so neither one of them have the operculum, so I can't, and they both look like they were alive.
Mhm.
But this attachment process is about 10 hours, up to 10 hours. And I would find it difficult to hold that proverbial pencil to my arm for 10 hours without moving it. I would find it extremely difficult to hold something live that's squirming around for 10 hours at one point.
Mhm.
I mean, if two carriers attach themselves to each other, I would just automatically assume that they were meant for each other at that point.
Okay. Lisa with a question. I saw one of your carrier shells with a coral attached. Would that be an advantage or disadvantage? And could one of those corals become recolonized, meaning a live animal on a carrier shell?
Yeah, so I mentioned in the study that was published in the Nautilus that they had found live coral polyps and live corals on some of the specimens in the collection, or they were live when they were collected, is what they were referencing. So yeah, and I mean it's in. So you look at corals; they're filter feeding, and that is a benefit to them by being in a mobile environment, especially on an animal that stays above the substrate. If that animal was a burrower and all of a sudden that coral was under the substrate, that would not be beneficial, obviously. So yeah, I mean, you see, this is one of those things to where I don't know if anyone's ever formally classified that as a symbiotic behavior, but I can really see that being beneficial to both the carrier shell by that extra camouflage, that extra size, that extra protection, and it being beneficial to the coral that's attached to it. I mean, the same thing, the spondylus with the muricid, I don't know if that was necessarily beneficial to the murex, but it was definitely beneficial to the spondylus. So yeah, but when you look at a sponge versus carrier, I'd say it's beneficial to both.
Yeah. Okay, Joyce has a question. I might mispronounce. I have a Xenophora paligula,
Okay.
okay, with a reverse glass sponge attached to it. It is larger than the shell by far. Is this an occasion where the carrier shell picked up the sponge when it was young and both continued to thrive?
It probably, more than likely. I mean, the thing with those sponges too is, and again, I've not firsthand witnessed. That's where I'm so cautious when making blanket statements. Wasn't there for the process, didn't see it. I've actually never seen it in the wild myself. I do know that those sponges are much less weight than some of the other things. I mean, I would I would love to take, but it would be a destructive sampling. To take a species, to take a specimen and weigh it with all the rocks attached to it, and then remove all those rocks and weigh it again to get the size, the weight differential of, because some of these, I mean, some of these specimens I've handled in our collection that have limited attachments versus of the same species where one is covered in rocks, and sometimes the weight feels 2 to 3 times more.
Hmm.
And you're talking just an immensely strong animal. But those are rocks as opposed to those coral specimens or those sponges in particular. They're lightweight. I mean, some sponges you handle, you barely know you're holding them. They're so light.
All right. Well, Mr. Kidder, that's we're at the end of our question train there. Thank you so much. Thank you, audience, for joining. And Gary, thank you for your knowledge, for your passion for the subject, and thanks for being part of our field. You're a real asset to it. And we like having you around and being part of our museum community, just as much as you're a part of your own. So thank you very, very much for this presentation. Thank you, audience, for joining. And look for this. If you'd like to see a recording of it, as I said, it should be up within a couple of days. And please, spread it far and wide, and any others you see on there of interest. And yeah, we'll see you next time. Thanks, Gary. Thanks, everyone.